Okay, we're going to be working through some more ABG practice problems. This time we're going to be focusing in on full compensation. I've been getting some messages saying that people have been having some troubles with this concept. So let's go ahead and just dive right in and work through a couple of these examples. So let's say we have a pH of 7.36, PaCO2 of 30, and a bicarb of 15. Okay, so the first thing we do is we look at our pH value, 7.36. We see this is normal, so we write it in the normal column. Our PaCO2 is 30, which is basic, so we write our PaCO2 in the base column. And then we look at our bicarbonate, 15. 15 is acidic, so we write this in the acid column. So now it's time for our diagnosis, but remember now that our pH is normal and the other two values are abnormal, we have a case of full compensation. But now we need to look to see our pH and see which side of 7.4 does it fall on. So 7.4 is in the middle here. 7.36 is less than 7.4, so it is closer to the acidic side. So this means we are in fully compensated something acidosis. And then we look at our acid column and see which parameter is in it. In this case, it is our HCO3, which is our metabolic parameter. So we write down metabolic, and so this means we are in fully compensated metabolic acidosis. So our primary condition is metabolic acidosis, but our respiratory system is able to fully compensate enough that the pH is now back into a normal range. Okay, let's look at another problem here. We have a pH. We have a pH of 7.36, PaCO2 of 75, and a HCO3 of 40. Okay, so remember our systematic analysis here. We look at our pH, 7.36, which is normal. So we write down pH in the normal column. Our PaCO2 is 75, which is very acidic. So CO2 goes in the acid column. And then our HCO3 is 40, which is very, very basic. So write down the HCO3 in the base column. Now our pH is normal, and the other two parameters are abnormal. So which side of 7.4 does our pH fall on? So 7.36 is less than 7.40. So this means our pH is acidic. So we look at our acid column. In our acid column, we have a respiratory parameter. So this means we are in fully compensated respiratory acidosis. So our primary condition is respiratory acidosis, but the opposite system, the metabolic system, is able to compensate enough to pull the pH so it's back in the normal range again. Okay, let's look at another problem here. Say we have doing that same thing there. Okay, a pH of 7.44, PaCO2 of 27, and a bicarbonate of, let's say, 18. Okay, so using our systematic analysis, our pH is 7.44, which is normal. Our PaCO2 is 27, which is, it's more basic, so the CO2 goes over here in the base column. Then our bicarbonate is 18, which is acidic, so the bicarb goes in the acid column. So we have a condition here again where our pH is normal and the other two values are abnormal, either too acidic or too basic, and so we have to see which side of 7.40 our pH falls on. So what's our pH? Our pH is 7.44. 7.44 is greater than 7.40, so that puts it closer to the basic side. So we look at our base column. Our base column contains a CO2, which CO2 is a respiratory parameter. So we are in fully compensated respiratory what? Alkalosis. Okay, we have one more problem here we can do. Let's say we have a pH of 7.43, a PaCO2 of 49, and an HCO3, a bicarbonate, of 31. Okay, so going back to our systematic analysis here, 7.43 is normal. It's in our normal range, so pH goes in the normal column. Our PaCO2 is 49. It is acidic, so it goes in our acid column. And our bicarbonate is 31, which is basic, so it goes in our basic column. So once again, our pH is normal. The other two parameters are abnormal. So which side of 7.40 does our pH fall on? So our pH is 7.43. 7.43 is greater than 7.40, so that means it is more basic. So we need to look at our basic column here. And our basic column contains HCO3, which HCO3 is a metabolic parameter. So we are in fully compensated metabolic alkalosis. Okay, I hope these couple of practice problems cleared this up a little bit.